Let me introduce myself. I am product manager of Java ME SDK, and I'm also managing mission control, Java mission control, which is not a mobile product. So I did this demo last year too for the previous version, Java ME SDK 3.0.5, and this year we have released a new version, which is 3.2. So I would like to show you the new features that we added and also show you how you can program in Java for an embedded device. So we made a big announcement at the Java 1 keynote session about the big push into embedded systems. So I'd like to show you how you can leverage this technology to write your own application for embedded devices. So just before I get started, how many of you have tried building applications for mobile phones? Maybe not embedded devices, but mobile phones. Okay, and I believe all of you are familiar with just Java code, Java language, because I'm going to show you how to just, I'm going to just code on live. So hope that helps. I'll spend little time on slides and try to spend more time on the live demo. Let me. Okay, so can you pull up the slide? Or should I do that? Okay. Uh-oh. Later. No. This is fine. Got it. Okay, looks beautiful. So yeah, so what's new in 3.2? Java ME SDK, when people say SDK, it can mean different things. Android SDK, iPhone SDK, they all have different components. When we call it SDK, we mean these four components. The first one is device emulator. I believe I can use this. Or laser. This one? Okay. Device emulator and development environment for assisting of writing, running, and debugging. And we also include some sample codes. Lastly, we also provide IDE plugins so that you can, you don't have to do manual integration yourself. You can just simply install these plugins in your IDE, either NetBeans or Eclipse. Once you do that, it's just integrated with the IDE. So if you just click run button in the IDE, then this Java ME SDK emulator will run instead of the traditional, Java applets or Java application. We also have this on-device tooling architecture, which I'm going to show you right away, right after this, which is we have this something called device manager, which manages different devices. So it doesn't matter whether the device is your emulator or the device that we provide or we recommend, or whether it is a third-party device, which is so as long as these devices have the runtime, Java runtime, and as long as those runtimes support the protocol that we designated, then this will just work fine. So here are just short summary of this release highlights. First of all, implementation of OJWC. So when you say implementation, it means it provides the full emulation for this specific runtime. So both Java wireless client and embedded runtime, we support both of them. And we started to support this information module profile next generation. So this profile, so you may be familiar with MIDP profile. This is a new profile for embedded device. So it's called IMPNG. We also added this new device skin creator, which also I'm going to show you later. We added support for Eclipse, profiling, network monitoring, and all kinds of monitoring tools, which I will also show you later. we also have App Update Center. So these are main features. ID integration, as I said, once you have this integrated, when you click Run button or Stop button, when you click Debugging button, then all your application will run on this emulator. CPU profiler means you can profile your application and see which method and which code blocks are using most of your CPU time. Memory monitor, which means you can monitor your memory in real time, current usage and the maximum usage of the memory. And here you can see how each variables or blocks are, how much they are taking up the memory. And debugger, so debugger means, so as I said, once you start debugging session from here, you can start debugging either on your emulator or on the device. This is a new emulation environment that we have added in this release, which is embedded application development. So you can see how it's different from this screen over here. That's the emulator for mobile devices. And here's the new emulator for embedded devices. So embedded devices, you want to control this general purpose I/O or I2C, SPI, memory mapped I/O. These, you want the emulation for these ports. So we added these features. Lastly, which I'm also going to show you, is on-device tooling. Custom device skin creator. Yeah, this is the last. So you can specify. We call it skin, but it's not really something graphical. It's not about the graphic skin. Actually, this is a configurator in a way. So you can configure your own device, what type of keypad it has and what type of screen resolution it has. This on the left side, it's for mobile device skin creator, and on the right side, you see the embedded device profile creator. Okay, let me show you all of these in live demos. Okay, thanks. So what I have here right now, I have this NetBeans ID running, and I also have this device connected to my computer. It's a bit difficult to see, but it's a ARM11 cortex board. Here's the CPU, and it has all type of peripheral devices for developers. So you don't, your end product might look much smaller and much simpler, but while you're developing your own application, you want to use all these peripheral devices for testing. So it comes with 2 USB slots, and here's the Ethernet slot, GPIO, and here's a link to the debugger, and you can put your own micro SD memory card into this board. Here's the audio volume controller. There are 4 buttons here and 8 LEDs. Yes? I'm sorry? Oh, this is called Keil, Keil. So if you just go to keil.com or keil.com, that's apparently the last name of the person who designed this device, Mr. Keil. So what I am using, this model number is STM32F200. So you can actually, you're going to be able to find this information from our OTN, Oracle Technology Network, later once we have this binary uploaded on the website. It's not there yet, but we are releasing the binary soon. So what we did was to implement a reference code, reference runtime for this specific board so that you can just download it and install it on your device and test it. I can also show you how you can install that. It's a simple process, how you can install, download your own runtime into this board. There are some serial ports here, LCD as you see here, and there is even a camera, small camera, which is quite powerful. So this is the board that I'm using for testing. Once you have this board, I think I bought it at $350 and plus tax. And I'm sorry?
I have a question. So does the device that you're trying to write does that plug into that physically, or do you
Yes, that's a good question. So I'm using this USB cable. It is plugged into my computer through this USB. I'm also using this Ethernet cable just because I want direct connection with my computer. But you don't really need direct connection. So I just want it to be stable, and I want the IP not change. So I'm using this direct connection. But in usual cases, what you can do is once you have two Ethernet cable coming from your router, you can plug one to your computer and the other one to your device. And this device will dynamically get the IP address through DHCP protocol.
actually what I was asking was,
Yes.
does your device plug into the tile, or does the tile maintain is that the emulator for the device? Like if you're trying to write code for a thermostat,
Yes.
is that physically plugged into the tile there, or is it, I guess I'm confused on how the tile interacts with whatever it is you're writing code.
So if you want to develop an application for thermostat, so this is your controller, hardware controller, right? It has the CPU and everything. So you want your peripheral devices connected to this board, the Kyle board. Then you can use your Java application to control your peripheral devices. That's how it works. This is a mini computer, basically. So you can actually see those live demos once you go to that demo ground. And they have this robot that reacts to external environment. When you put that flashlight into the house, then it turns on the switch. And if the temperature goes up or down, then it cools it off, and the heater turns on automatically. Those type of things. You can control them. So let me get started. First thing that I want to show is how you have this. Once you have this Java ME, once you install the plugin into NetBeans, then you will see these menus. I'm using device selector for the convenience of launching my application directly from here. For now, I don't need these two. I only want to show this. So the first thing that I want to show is when you write an application for this type of board, what you usually do is to download the SDK from Kyle. And then once you have this, you can write your own C code to control, for example, LEDs. So this is a Blinky project, which is controlling your LEDs. If I run this application, it will blink LEDs from 1 to 8 back and forth. So that's the code. Let me go back to Java code. Intentionally, I have a blank code here, so I can start from something very simple. So once the application is started, I want it to print out hello world. So those are emulators. So I added these two devices later, but once you first install, you only have these two. So if I just run this application, and you'll see it starts running the emulator, and it will print out the result here. It does not have LCD screen, so you don't see anything visual on this emulator. But another thing that you can do is you can generate external events and send it to your device. So think of this part as your device, which has GPIOs, I2C, and MMIO. I'm sorry if you're not familiar with these terms. These are just peripheral or input output terms for this type of device, and these are like pins. So there are 5 pins connected right now. So 2 LEDs and 3 buttons. We are assuming that this device has 2 LEDs and 3 buttons, and you can send these events to your device from this event generator. So once you do that, next thing you can do is maybe something. Next thing, let me try something more. Let me just try to run this application on the device first. So here you see external phone. It's not really a phone, but we just call it phones, all of them. This external device is actually referencing this device. The way I added this device was by just adding the IP address. So on this screen, so I have set the IP address already for this device. Yes.
The JRE, it goes on top of what exactly? I mean, is it something that comes with file or?
No, yeah, that's a really good question too. So Java runtime, it doesn't go on top of Linux or any other OSs. It goes directly on the board. So when you reboot this board, it doesn't load any OS, and it starts Java runtime right away.
So it's like Java runtime on bare metal.
Yes, right. Not metal.
Something like, like a stack or something?
Yes, there is. So there is something in this board, such as RTOS, we call it. It's not a separate OS installed on this board, but it has its own controller, of course. Basic software kernel, and then Java is communicating with this kernel. Yes. So I can try to run this application on the device. So I was talking about how you can add your device so that it is detected. So currently, this device has the IP address of 192.168, 120, and 10. So if I add, it says the device is now available. So it tries to probe the device or runtime at the specific IP address. Once you detect the Java runtime, then it connects this runtime to the computer. So, and then it adds this here, right here. You can also see that, you can also do that from here, managing device address. Once you add this device, then you can run directly on the device from your IDE. So let me open this session, logging session. You see that starting Java ME Embedded, this is a just typical PuTTY terminal session that I have preset those IP address. This way I can connect to the board through Ethernet, and then I can look into the board. Another thing you can do is to open an application management system. So I'm working in the board right now, so there are a couple of commands that I can use. AMS list means all the give me all the applications that are installed or that are running on this device right now. So it is giving me the list, and you can do all the other things here. Yes.
So the applications are basically midlets.
Midlets?
Yeah.
Oh yes, correct. I'm sorry. So it is basically a midlet, as you can see here. It's importing midlet, but you cannot use any graphical operation here. It doesn't have LCD. We don't support LCD yet. So as you see, it just has printed out hello world here. Let me terminate this application and try something more sophisticated, more fun. So here's an application that I wrote just to see how I can control this GPIO. So my goal is to turn on these LEDs here when I press these buttons. So I want to play with this, interact with buttons and LEDs. To do that, first thing you need to do is to import this GPIO device access. Once you do that, let me just define a couple of static variables. And here's what I want to do. Going through all the LEDs and assign LED pins on I. So that means I want to assign these LEDs GPIO manager.get pin. It tries to get the reference for each pin on the pin number I. So I assign these LEDs to here. I need to actually try and catch this code block. So as I finish assigning that, another thing that I want to do is to assign buttons to each pin. So these codes are doing the same thing. GPIO manager.get pin for specific index, and then I want to allocate these to my button variables. So, and then I can set input listener for each button. When I press a button, I want to do some specific things. So when I press button, when the value is changed, it gets the pin number and tries to identify which pin it was. So if the pin is wake up button pin, so this means there are 3 buttons. One is called wake up. The other 2 are temper and user buttons. I have 3 buttons. So I want to do this operation when I press wake up button, and this operation for temper button, and this operation for user button. That's it. That's basically what I want to do. So here inside the code, you can see how, what I'm trying to do here. So when I press wake up button, I want to turn on LEDs from 1 to 4 by setting the value to true, and pause a little bit and move on to the next LED. 1, 2, 3, 4, and then turn off the LEDs from 4, 3, 2 to 1. So that's what I'm trying to do here. Let me just copy this block of code. It's pretty straightforward. Into start, and I just need to add this code to the destroy to clean up when the application is destroyed. So I can test this on the emulator first before I run it on the device for debugging. So to do that, this time, you see how my default emulator had only 2 LEDs, but I now need 4 LEDs, right? I'm using this application for controlling 4 LEDs. To do that, I can create my own skin which has 4 LEDs. So here, I need 1, 2, 3, 4. I'm not going to use ID 0, so I'm going to add 4 pins, and these 3 pins are for buttons, and these are outputs. So I can name this like LED 1, LED 2, and so forth. I can name this to button 1, button 2, and so forth. Got it? So I don't need any I2C, SPI, or MMIO, so I'm not doing anything. And I need these optional packages. So if I just click OK, it will try to add one more device. It is registered, and you'll see it from here. This one I created. So I can run my application on this emulator that I have just created. So it has assigned all the pins on LEDs and buttons. So let me go here and check out my application first. I don't use this pin 0, so let me just ignore that. If I press pin 5, that's what I want to do. Here, turn on the LEDs from 1 to 5, and this one turn the LEDs from 5 to 1. So you may notice that actually when the state is off, then the LEDs are turned on. This is because of the internal implementation of this board. Actually, for tempering user buttons, when it's released, then it returns true value. So I have reversed the behavior here. Once you have verified the application in action here, then you can run this application on the device. And let me open this logging so you can see how it goes. It tries to assign those LEDs 1, 2, 3, 4, and 5, 6, 7. So now the application is running on my device right now. So here are those buttons. When I click wake up button, I want those 4 LEDs turn on one by one. You can see just those lights from here. And if I press the other button, I want the LEDs to be turned on in reverse action. And then last button, I want all of the LEDs be turned on. And when I release it, all of them turned off. So that's how you control. So you can also control this joystick here by using I2C, and you can also control your own robot if it's connected to this device. Yes?
All the ports are all digital or analog as well?
Oh.
ADC as well?
Right now, all the ports are digital. We don't support analog.
So, connecting any sensors would be possible?
No, actually, you can also connect sensors. You know what? I'm not super clear about this, so I wouldn't just give my words. But you can see those sensor demos at the demo booth. It has heat sensor. It has light sensor. You can connect those sensors, and it reads those information from those sensors. So I assumed that those sensors were giving back digital information, but you can double check. So next thing that I want to show is, once you see that application is running fine on the device, what gets more interesting is when you can actually do your own debugging on the device. So let me put a breakpoint, maybe around here, set value true, and line breakpoint. Where is it? Toggle line breakpoint. I set the breakpoint here, and then start debugging session. So before I do that, let me check my platform is set as external phone, external device. And then if I click debug, okay, I believe it's connected now. So it starts the debugging session, and let me see. I'm sorry, it worked, 30 minutes ago. Let me try on an emulator first. So start a debugging session. Yes, it has actually stopped here. You can see those variables. All of these, and then you can do step operation, step by step, and see how your application runs. So it works fine on the emulator. It also worked on the device, but let me try once more. If it doesn't work, next time it should work. Okay, I'm sorry about that. So what it did 30 minutes ago was to just run the application in debugging mode on this board. So I can just press F8, press step by step, and watch all those variables. So this way you can do on-device debugging. Let me switch back to this emulator mode and show you a couple of more features that we have added, such as profilers. So here is my application, GPIO test, and I want to profile this application. So just right click this and go to profile and integrate the profiler. Before I do that, let me switch that. Yes, it is IMPNG phone. Okay, good. Click profile, CPU profiler. Usually I do this with the mobile application. So it is running, it stops. Now you can see, this is too simple application to show you this, but basically what it does is, that application spent most of the time in that startup method. As you can see from the code, most of the logic is in that start app. So that's where it spent most of the time. I can try with a different application, Java ME, and something more interesting. So try to profile this one, CPU profiler. Oh, I'm afraid it was pointing to a wrong platform. Yes, actually, let me switch it to this and try again. Because I don't want 305. That's an old version. So let me try again. Profile, CPU profiler. Yes, here's the application. Now that's the application. So go back, and if I go to Gauge, for example, run this application, this type of simple application, when I exit, it gives you the profiling result. So in this result, if you want to go to this, you can just double click and go to that method and see what's in there. That is CPU profiling. Also, this is the new feature that we added, memory profiler, memory monitor. That one is also giving me a hard time. Let me see. Let's try. Okay. Once again, memory monitor. So here, what you are seeing right now is the live status of your memory. It is using this much byte. Once it does garbage collection, it will go down, and when you play with this application, it will also impact your memory. And you see these are the number of objects and total number of bytes and average size per those objects. That's it. Something else you can use. So far I've shown you how to just write and test your own embedded application using Java ME SDK. Also how to connect your board to your computer and make it recognized. also how to use profiler and debugger. You can do pretty much the same thing on Eclipse because we are providing those features on Eclipse platform too. So for more instruction on how to set this up, how to install these plugins, those information is all available on the website, OTN website. When you go to that download Java ME SDK page, then you can see all of these. Or we also provide user guide. So those are the demos that I wanted to show you today. If you have any other questions? Yes? What type of requirements? Oh, okay. I guess you're talking about those embedded devices, right? So this device, you know what? Just 1 second. I can show you that. The whole. Yes, here it is. So this is a specification of this device, this specific device. It has ARM 32-bit Cortex M4, 168 megahertz maximum frequency, and 1 megabyte of flash memory, SD-RAM. And these are peripheral stuff. So these are not defining whether whether you can run this or not. So let me see. Another thing that I can show you is Java embedded. So that's the binary that I am using. So this is the one that I'm writing on this device, Java VM AX file. It's 10 megabytes. So that's the size of the runtime that I'm using. So as long as your flash memory, so yes, as long as your flash memory has that much space. There is also a demo of running a simple, just a real Java ME application, so it's experimental, but we have a Java mobile application that runs on this device. It is a bit slow, but you can see how you can actually play a game, like breaker game, using this device, using the joystick. Any other? Yes. Oh, from the VM. Yes, the VM has to provide. Hello. So the VM has to provide those information. So Java ME SDK does not really pull those information from the runtime. The runtime supports profiling, and runtime produces those information while it's running, and then through this channel, SDK can just take that information from the runtime and show to the users. Yes, it doesn't have to be a debugger mode. Yes, it's just a normal mode. It still produces those information, but it adds overhead to the VM for profiling. So when I run the application, what it actually does is to give the option to start the profiler, memory profiler or CPU profiler, when running the application. So once you turn it on, then it adds this overhead to the VM, basically. So we are trying to minimize the overhead because we don't want this profiling or monitoring as another unnecessary layer to the result. So that's another, those are the projects that we are working on. Heap size. So Yes, actually, it's not monitoring stack memory. Right now, it's showing only heap size. So we don't show stack allocation at this point. Heap size, yes. Okay, I guess no more questions? Yes, please. Yes, with the UI. Oh, okay. If you want to create an application with some graphics, then you can also use this SDK. So what I showed today was only the embedded part. So you didn't see any LCD graphical part. But actually, I also showed you that UI demo. So that has the graphical part. You can test your graphics on mobile emulator. Yes. So a few years ago, you saw this display appearing. Yes. Yes. Oh, I see. I see what you mean. Right, right. Yes, yes. The application looks different on different phones. Yes, it was the case. Right. So, you know, that's actually the reason why we provided a library, graphic library, which is called LWIT, LWIT. So because of that issue, developers wanted the same look and feel across all those devices. So you can even create your own library, graphic library, or you can use one of them available out there. And one of them is LWIT that we have created. Yes. Yes, library. Yes?
Is there any overlap with Android or I mean, do you guys intend to put all operating systems for phones that use Android or?
Yeah, we get that question a lot, many times, but it's just I was instructed to say I'm not able to comment on that. Yes, we get that question a lot. Yeah, we are both are using Java, obviously, but Android and Java mobile, they use different VM and different instruction code. So the internal implementation is quite different. Okay, I guess that's it. Thank you for attending and listening to this presentation. Thank you.